Hi friends, my name is Ans and you're watching Education Planet. And friends, our today's topic from physics is simple harmonic motion. Friends, what is simple harmonic motion? Before we start something, just assure and think about vibratory motion. Know about vibratory motion. A vibratory motion of a body, it seems like this, that we have this ball. If with some circumstances this ball comes back and goes forward to upside, it's called vibratory motion. And the same if a ball is attached with spring, if it comes forward, goes back, it's a vibratory motion. Every vibratory motion of this ball is like this. It goes to its extreme position and then mean position and then the lowest. So a simple harmonic motion consists of body that moves forward, backward, to and fro from its mean position. Let's suppose we have a spring that is attached with a rigid body. And with spring we have a mass. This is our first condition. Let's see the same spring with a mass, with the same spring, a simple harmonic motion consists of a body, of a mass that is attached with something that can move this that can move this mass to up high side to low side, sometimes to forward, sometimes to backward. So in these conditions we have first condition A. Here the force is equal to 0 and there is no displacement in first condition, and then we just compressed with this, we apply some force here. When we apply some force, it going vibrating. With this, the mass is coming backward. Here is x is not 0. Because when we compress it, this mass has gone to this position, So here x is not 0, but here x was 0 and the force is also not 0. So the force we applied to this. In the next condition, the mass after compressing it released and it goes very high. So here This is our x, and the force is to forward. So friends, in this example with simple harmonic motion, this mass is doing a simple harmonic motion because it is attached to a spring with a rigid body, and it released it. Sometimes it goes forward, sometimes to a backward. It is due to a vibratory motion, and it is due to a restoring force. This is a restoring force in a spring. All the spring has restoring force. So the formula we can discuss here, F is equal to minus kx. Here F is a force. Here this is a spring constant. And here x is our displacement or a distance. So friends, we have concluding this. So now let's see this spring constant. We can say K is equal to F over X. So as we know by the Newton's law of motion, F is equal to ma. So we are putting ma here. K is equal to minus ma over x. So as we know that we are finding our acceleration of a mass during this process. This A we are taking outside. We can say minus K over m x. So A is directly proportional to x. So friends, with this all conclusion, we can say a body that is doing a simple harmonic motion has a restoring force of this spring. Sometimes this mass comes to forward, sometimes to backward due to restoring force. Due to this, the force is not zero. The force every time it changes, and the distance is 2. Then we put some formula by the Hooke's law. F is equal to minus kx, and then with a constant spring constant we find spring constant, and then putting a formula of a Newton's law of motion, and then we find the acceleration that is directly proportional to its distance or displacement. So friends, where is our kinetic energy and potential energy maximum or minimum. This is our spring that is attached with a mass. When a mass is at its high position, its maximum strength, here is kinetic energy 0 and potential energy is maximum. Okay friends, and when a mass is at low position, here kinetic energy is 0 also and potential energy is maximum. And friends, when it is not moving, here is kinetic energy maximum and potential energy is 0 or minimum, you can say. So it is how the whole phenomena looks like when a spring attached with a mass, then doing a simple harmonic motion with a vibratory motion and storing force inside. So friends, this was our topic today. Thank you so much for watching. Wanna see you in the next video. Goodbye for now.